I'm Andrew Huberman, and I'm a professor of neurobiology and ophthalmology at Stanford School of Medicine. Today we are going to talk about science-based protocols for sleep, mood, learning, nutrition, exercise of various kinds, strength and endurance, and hypertrophy. And we are going to talk about some protocols that relate to creativity. We're going to talk about behavioral protocols, supplement-based protocols, all science backed by quality peer-reviewed literature. So let's talk about how to apply quality peer-reviewed science to your day and how to optimize everything from sleep to learning, creativity, meal timing, etc. As I mentioned earlier, I'm going to do this in the context of my day and what I typically do. However, the specific protocols for any number of different things, sleep, relaxation, meal timing, exercise, etc., any one or all of those could be rearranged to suit your specific needs. I'm going to tell you what I do from morning until waking and even what I do while I sleep in order to optimize my sleep. So let's start with getting up in the morning. Now, for me, I tend to wake up sometime around 6 a.m., 6:30, sometimes as late as 7 a.m. I don't typically sleep much later than 7 a.m. The first thing I do after I wake up is I take the pen that's on my nightstand and the pad of paper on my nightstand, and I write down the time in which I woke up. Now, I do sleep with my phone in my room. I realize this is considered a sin and has certain hazards associated with it, but I put my phone on airplane mode about an hour before I go to sleep, and then I set my alarm typically for 6:30 a.m., and some days the alarm wakes me up. Other days I wake up before the alarm, and yes, some days the alarm goes off and I hit snooze a few times, and then usually by 7 a.m. I am up and out of bed. The reason for writing down what time I wake up is because I want to know that average wake-up time. That average wake-up time informs what's called my temperature minimum. It tells me when my body temperature was lowest. The temperature minimum is the time in each 24-hour cycle that your body temperature is lowest. I don't sleep with a thermometer in my mouth or elsewhere, and I don't think you should either. Instead, I know that the lowest temperature that my body will be at across the 24-hour cycle tends to be 2 hours before my typical wake-up time. And I want to know that number. It's called our temperature minimum. So if you're somebody that typically wakes up at 8 a.m., then your temperature minimum is sometime around 6 a.m. Remember, the temperature minimum is a time in the 24-hour cycle. I don't care what my actual temperature is. I care when my lowest temperature is, and I know that that lowest temperature is approximately 2 hours before my average wake-up time. So I highly recommend that you write down when you wake up or track that in some way that works for you and use that as a reference point to determine your temperature minimum. We will return to the temperature minimum and how you can leverage the temperature minimum for several things: shifting your clock, shifting your circadian sleep schedule and wake schedule, also for shifting your eating schedule, etc. We will return to that. But even if you don't travel, even if you don't care about things like jet lag, even if you sleep fabulously all year round, never have a poor night's sleep, knowing your temperature minimum, that time when your temperature is at its lowest point, is a valuable thing to know. The second thing I do after I wake up is to get into forward ambulation, which is just nerd speak for taking a walk. Now, I have a dog, and as many of you know, he's a bulldog, and he doesn't really like to walk, especially not in the morning. But for humans and for animals, there's a phenomenon whereby when we generate our own forward motion, forward ambulation, visual images pass by us on our eyes, so-called optic flow. And for those of you that are low vision or no vision, the same phenomenon occurs in the auditory system. Sounds pass by us in so-called auditory flow. Getting into a mode of forward ambulation and especially experiencing visual flow has a powerful effect on the nervous system. The effect it has is essentially to quiet or reduce the amount of neural activity in this brain structure called the amygdala. Amygdala means almond, and many of you have probably heard about the amygdala for its role in anxiety and fear and threat detection. And indeed, the amygdala is part of the network in the brain that generates feelings of fear and threat and anxiety. It does a bunch of other things too, but that's one of its primary functions. There are now at least half a dozen quality papers published in quality peer-reviewed journals that show that forward ambulation, walking or biking or running, and generating optic flow in particular, has this incredible property of lowering activity in the amygdala and thereby reducing levels of anxiety. There are two papers that I'd like to highlight in particular that relate to this phenomenon. The first one was published in the journal Neuron, and the title of this paper is Whole Brain Functional Ultrasound Imaging. That just means they have a cool technique to evaluate the activity of structures in the brain across the entire brain, reveals brain modules for visuomotor integration. What they found in this study, and I should mention the first author is Masse. This comes from Botan Roska's group. This was work done in mice, but I will talk about other species in a moment. What they found was essentially that when these mice walk forward and their eyes move from side to side, which is a natural consequence of moving forward, so-called optic flow is flowing past their eyes, many brain areas are activated, increase in their level of firing, but the amygdala in particular reduced its levels of firing. That's a very interesting finding, but it is in mice. However, another paper, Eye Movement Intervention Enhances Extinction via Amygdala Deactivation, was published in the Journal of Neuroscience, a strong journal, and shows that, again, these eye movements, these lateral eye movements from side to side, reduce activity levels in this fear/threat/anxiety center in the brain, the amygdala. Now, those are eye movements. They didn't specifically look at forward ambulation, and yet other papers have looked at forward ambulation, and we know that forward ambulation, walking forward, generates the sorts of eye movements that cause optic flow and reductions in amygdala activation. So for me, this process of taking a walk each morning isn't about exercise. It's not about burning calories. It's not about any of that. It's really about getting into optic flow and reducing the levels of amygdala activation. Now, I don't have anxiety. At least I don't have chronic anxiety or generalized anxiety. I tend to have a lot of energy, but at these points in the morning, I'm not very energetic. Sometimes I'm sort of shuffling more than I'm walking, in fact, and Costello is almost always shuffling, and I'm almost always trying to drag him first thing in the morning. But that walk is a particularly important protocol each day because it really serves to push my neurology in the direction that I'd like it to go, which is alert but not anxious. And it's kind of a fine line sometimes, especially as events surface throughout the day, emails come in, text messages come in, get bombarded with a number of things. I want to be alert and responsive. I want to be able to focus, but I don't want to feel anxious or reactive to these things. So the forward ambulation and this optic flow is the way that I ensure, based on quality peer-reviewed data, that my amygdala activation is slightly suppressed. Now, at the same time, I also want the alertness. I want alert and focused. I don't just want to be sleepy or super relaxed. I want to have a high degree of focus and alertness because I'm soon going to move into a bout of work. I need to lean into the day.